With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. Let's start our question. The question says that standard enthalpy of vaporization, that is delta H naught, for water is 40.66 kilojoules per mole. The internal energy of vaporization of water for its 2 moles will be, and here are 4 options provided. So basically in this question what we have to look for, here we are provided with the standard enthalpy of vaporization value for water, which is given to us as 40.66 kilojoules per mole, and we have to calculate the internal energy for vaporization of water for its 2 moles. So let us have a look at the solution to our question. If we go as per the question, the enthalpy of vaporization which is given to us, for the enthalpy, for calculating the enthalpy of vaporization, how the conversion must have gone. Here for vaporization means that water is getting converted from its liquid state to its vapor, or we can say the gaseous state. This is how the conversion is taking place, and the value of enthalpy of vaporization for this is given to us as delta H naught. For V stands for vaporization, 40.66 kilojoule per mole. We can write mole inverse, it means per mole. Now here we have to calculate the internal energy for 2 moles of water. So how we'll do that? First we'll calculate the value for 1 mole and then we'll multiply it by 2. Now having on the look to another very relevant information which is not being provided here, we know that water boils at 100 degrees Celsius. So here the boiling point of water we know is 100 degrees centigrade, and if we convert it in Kelvin scale, we have to simply add the value 273 to it, and in Kelvin scale the temperature will be 373. So this is something which was not provided in our question and we will be required. So if we use the relation, how delta H and internal energy are related to each other, they are linked to each other by this particular equation which goes as delta H naught is equal to delta E naught, or in some books you'll find internal energy written as delta U naught. E and U both stand for internal energy. You can use any of these symbols, plus delta NGRT. This is the equation through which we'll evaluate the change in internal energy. Let us number this equation as 1. Now, what we have to find here, we have to find delta Ng. What does delta Ng stand for? Delta Ng stands for change in number of moles of gaseous molecules of a gaseous species. So here, if we go as per this reaction, gaseous species here is H2O gas. Here there is no gaseous species. So how we'll calculate the change in number of moles of gas? The moles present in the product side minus the moles present in the reactant side. So it will be 1 mole is present on the the product side, whereas 0 mole is present on the reactant side. On simplification, we'll get this value as 1. So delta Ng will be 1. Now, if we substitute all the given values in this equation number 1, our expression will become as 40.66, which is the value of enthalpy change of vaporization. It will be equal to delta E naught, that is change in internal energy, plus 1 for delta Ng multiplied by gas constant. R stands for gas constant. Its value in joule is 8.314, but here we are talking in kilojoule as the delta H value is given in kilojoule. So we have to divide it by 1000 in order to make it converted for kilojoule. This we are doing to convert it for kilojoule, as this particular 8.314 value is in joules. The unit is joules here. and we'll multiply it by the temperature. Temperature is nothing but just the boiling point of water, which is 100 degrees centigrade, and in Kelvin scale it is 373 Kelvin. So this is our expression. In order to get our final answer, we have to simplify it a bit further. Now, on further simplification, we get the expression as 40.66 equal to delta E naught, because this is something which we have to find. And if we simplify this term further, if we divide 373 by 1000, we'll get the expression as delta E naught plus, there's a positive sign in between, 8.314 multiplied by 0.373. Now, again, if we simplify this further, we'll get the expression as 40.66 equal to delta E naught plus 3.10. Now here we have to evaluate the value of delta E naught. Here it is in plus. If we take this particular side to the left hand side, then we'll get the final simplified answer for delta E naught, that is change in internal energy, as 37.56 kilojoules per mole. Now per mole means this is for 1 mole basically. So this we have evaluated the change in internal energy. How? We have just subtracted this value 3.10. We took it to the left hand side and we subtracted it from 40.66. So this is how we got the value for 1 mole. Now, as for the question requirement, we have to evaluate the internal energy, change in internal energy for 2 mole. So for 2 mole, what we'll do is, if we number this equation as 2, we have to just multiply the equation 2 by 2 only. So we'll get the value for 2 moles. So here the final answer will be delta E naught is equal to 2 multiplied by 37.56, and our final answer will be 75.117 kilojoule. So if we have a look at the options given, so this particular value matches to none of the options given. So here option 4 will be our final answer, that none of the given options are true, holds true in this particular case. So our final answer to this question will be option D. Option D is correct. That is, none of the options are correct for the question being asked. This was all about our question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.